some time here, so that's great. I think we can get started since breakouts have officially started. So welcome to day 2 of Verge Electrify. We're the first session of the day, so it's just really exciting to have you all here early and to be going through these innovations on the showcase that will be electrifying buildings. So we'll get started. My name is Sherrie Totoki. I'm the Director of Startup Programs here at GreenBiz, and I'll be moderating this fantastic session with our innovators here. So before we get started, a few housekeeping items. The sessions will be recorded, and recordings will be available within 24 hours on our replay section in Hopin. We'll also be sending out the official recordings about 2 weeks after this event. And then lastly, about 10 minutes before the session ends, there will be a survey on the right-hand side of the screen in the chat box. Please take that survey and give us some of your feedback. So here's how today's session is going to work. We have these 5 exciting innovators with us today, and each of them will have about 5 to 7 minutes to be talking about their innovations and their technologies. And it's going to go pretty quickly. So as folks have questions, please drop them into the chat. We'll try to get to them as we go. Otherwise, we'll address them at the end. You can also chat with people after this. So this session is just kind of a quick taste of all of these different technologies, but you can always contact people afterwards by toggling over to the People tab and reaching out to follow up. And I believe that is it. So Manik, I think we can get started with you. If you wanted to share your screen, Manik from Therma, thank you for joining us.
Awesome. Thanks, Sherrie. Great to be here. Hopefully you guys can see my screen. Happy, hump day. Great to be here at Verge Electrify. My name is Manik Suri. I'm the founder and CEO of Therma. We're trying to build the world's first clean cooling platform. This audience knows well the challenges around the energy transition and the need for significant improvements in existing infrastructure, as well as massive advancements in new asset generation and distribution. But I think sometimes the unsexy and obvious gets overlooked. Our goal and our vision is to make cooling cool and clean. We see a huge cooling crisis. Right now, refrigeration and air conditioning, the cooling sector, are responsible for nearly 10% of all warming when you think about the impact that refrigerant leaks, energy consumption, and product spoilage at scale have on the ecosystem. There's just a massive amount of warming caused by this sector. Kind of hard to fathom that nearly 10% of warming comes from cooling. There's a lot of economic waste as well. In an annualized basis, you've got billions of dollars that are wasted on inefficient and poorly optimized assets that are just burning energy and using electricity in ways they don't need to. Tens of billions are lost in product spoilage, and huge amounts are spent on asset maintenance and replacement when they don't need to be, because these assets currently don't have good data coming off of them and are not being optimized or managed intelligently. We think that the cold chain, the refrigeration piece of cooling, is large, dumb, and growing, and a real interesting area to focus on as part of the energy transition and as part of building climate technologies. There are trillions of dollars of assets, food, pharma, and data that flow through the cold chain, 3 of the most important assets in the global economy. There are 90 million stationary fridges and freezers in the business world, so commercial refrigeration, not including the 1.4 billion residential. And most of that inventory, most of those pieces of equipment are dumb. They're not connected to the cloud. They're not optimized with data science. And this sector is growing at 8% CAGR globally and 15% CAGR in the developing world, because a lot of the world doesn't have adequate refrigeration today. So this is already an existing large infrastructure layer that's growing rapidly and dumb. We're trying to build clean cooling as a multi-phase journey. We're starting by monitoring. As the saying goes, you can't manage what you can't measure. Once we can monitor, we can start controlling these pieces of equipment. And then ultimately, by monitoring and controlling, we can start to optimize them. We sometimes describe this as a Nest model, similar to what Nest has done on the residential HVAC side, but for commercial refrigeration. So the first thing we built at Therma was the best-in-class monitoring solution. We used a new type of IoT connectivity layer to create a sensor product that uses long-range radio to get signal out of the inside of refrigeration reliably. This was hard to do with Wi-Fi and Bluetooth, and so most companies didn't deploy wireless sensors. We've been able to use LoRa, long-range radio, to get signal out reliably and with low battery consumption. We're also offering this product as a do-it-yourself kind of drop-in-place installation. No technicians and no hardware required, no hardware costs or implementation. It's a pure drop-in-place sensor. And the business model as a result is highly scalable. It's a SaaS offering. So we sell this on a subscription basis. Over the last 2 years, we've gone from 100 sensors to over 10,000, from a couple of customers to over 1,000. We're doing 15% month-over-month growth, and we've signed up some great logos, operators of brands like McDonald's, Pizza Hut, Domino's, Taco Bell, up the supply chain, distributors like Now Foods, UNFI, Kreider, and large cold storage warehouse players like Lineage and US Cold. The second phase of the intelligent refrigeration and clean cooling play is to turn refrigeration into a battery. And so what we've started doing over the last year is not just monitoring, but actually controlling refrigeration and creating savings for the customer that are not just around reducing spoilage and asset downtime, but actually lowering the energy footprint. Using a combination of peak shaving, load shifting, and demand response, we can create value by essentially tapping the refrigerator as a battery, taking advantage of the fact that you can move when and how power is consumed on that asset around to reduce the load and to save money. There's multiple methodologies at work. Shifting, shaving, and demand response each have value associated with them. I'm not going to get into details here, but essentially you can imagine turning refrigeration up and down dynamically, using it when energy is cheaper and cleaner, lowering the utilization when the peak demand hits, and when the utility needs that power for other purposes, we can lower consumption. This allows us to expand our revenue and charge more per location. So we're 6x increasing our revenue this year per customer, going from monitoring to managing their refrigeration. And ultimately, we see this as a stepping stone to controlling other assets and creating a larger footprint by enabling both asset efficiency, turning these pieces of equipment into more efficient assets, and also adding potentially storage, local batteries. You can imagine if you had battery power, you could do shaving and shifting for longer and create even more savings on these assets. And refrigeration, it turns out, is a great battery. It's one of those few assets in a location that can actually be turned off for short bursts of time without affecting product. The goal here is to build virtual power. We're trying to enable clean cooling at scale and ultimately be part of the energy transition as a virtual power player. There's a huge market opportunity. In the US alone, we're talking about a multi-billion-dollar annual sales opportunity. There's a lot of refrigeration. It's literally everywhere, and most of it is done. And so when we think about sectors, today we're focused on commercial, which is essentially small box refrigeration in your typical restaurant, school, university, hospital, pharmacy. But of course, there's huge opportunities in supermarkets and grocery and cold storage as well. And we think that we're just getting started. We're about 60 people on our team based out of the Bay Area. I live in San Francisco, so I'm living through the energy transition and the climate crisis firsthand, having grown up in California and seeing this. And I think our team is mission driven and believes that we can do good and do well, marrying profitability and sustainability. We'd love to connect, and if you're interested in learning more about opportunities, we're hiring. We're about to close our Series A next month, and we are very much interested in partnering with folks in the energy transition. Thanks so much for having me. Pleasure.
Great. Thank you so much, Manik. That's such a fantastic overview and staying right on time here. Really appreciate that. Love hearing about the refrigeration as a battery. And next up is Amrit, Robbins, also refrigeration, to continue the conversation here. And as a reminder, if folks would like to drop questions into the chat or the Q&A, great. Yes, I see some questions coming in from Gil. Perfect. All right. And I'll pass it over to Amrit.
Well, good morning, everyone. I'm really pleased to see over 100 folks in the audience today. And if you hear my dog barking in the background, ironically, it's because the refrigeration repairman is here at my house right now. And he's going crazy. So apologies for that. Can you guys see my blue slide? Perfect. Okay. So at Axiom Cloud, basically, Manik and his team are focused on the same problem set that we are, which is refrigeration. So, there's so many of these refrigeration assets out there that consume an enormous amount of energy, are very inflexible, and ultimately leak refrigerant like a sieve, which is one of the most potent greenhouse gases. And so we're focused on a different part a different kind of segment of refrigeration than Manik and his team. At Axiom Cloud, we're focused on the folks who already have really advanced sensing and monitoring and data collection assets. And so that's going to be really large distributed or large warehouses that are doing food processing, packaging, manufacturing, and warehousing, and then retail grocery. So those are our first target segments. So at Axiom, we provide the AI platform for buildings with large thermal loads. Like I mentioned, right now we're really focused on these first two segments, retail, grocery, and cold storage. Really, really large opportunity here. What's important to note is that for retail grocery specifically, which is most of our customers to date, there's about 60,000 retail grocery stores in North America, razor thin profit margins, and these folks spend more on energy and maintenance than they take home every single year in profit. If you dig one layer deeper on the P&L, it turns out that retail grocery spends more money just to power and maintain refrigeration than they take home in profit every month. And that's because refrigeration is the elephant in the room, consuming over half of the energy and 90% of the service dollars. Refrigeration is responsible for about 90% of service calls. So absolutely enormous P&L impact for retail grocery. And then beyond that, you also have to keep in mind that refrigeration is the most mission critical asset in the entire retail grocery business model. So, there's a lot of really visible impacts when cooling goes out. That's kind of the nightmare scenario, but it also affects every single other element of the entire business model, down to things like food spoilage and shrinkage, employee satisfaction and turnover, customer loyalty, cart size, number of visits per month. All those things start to trend in the wrong direction when you have recurring cooling outages. It's not fun if you show up at the grocery store and there's yellow caution tape in the freezer aisle. You can't buy half the things you want to buy. So despite all this, the massive P&L impact and the fact that this is the most mission critical business asset in the entire grocery business model, our customers today don't have the tools to address the root cause of the energy or maintenance challenges that this asset class refrigeration faces. On the energy side, our customers are spending a lot of time and money on efficient lighting, energy management systems, rooftop solar, et cetera. All that stuff is great because it reduces the quantity of energy consumed. But unfortunately for our customers, 70% of their bill is not driven by quantity, it's driven by timing of when energy is being consumed. And this is really bad news for retail grocery because they're one of the least flexible energy consumers on the entire grid. Again, because of refrigeration, it just chugs along 24/7. And then on the maintenance side, the status quo it's even worse, honestly. It's a completely reactive break-fix mentality. It's not data-driven at all. Basically, you cross your fingers and you hope for the best. And when things inevitably break down, it's not one display case in a grocery store because these are central systems. It's a third or it's a half or it's the entire store that's going down, all in one fell swoop. And so at that point, you mop the ice cream off the floor, and then you start calling local contractors and begging them to show up. It's a very, very antiquated and bad model right now. So at Axiom, what we're doing is we're taking this playbook, which has already been successfully applied at just about every adjacency, and we're applying it to buildings with large thermal loads for the first time. And that playbook, really simply, step one is get the data out of the machines where it's been locked away for years or decades. In our case, we're connecting to the refrigeration controllers, which are already collecting between 500 and 2,000 live data streams from each grocery store. And for the first time, we're making that data accessible to humans by putting it in the cloud. Historically, the data has been locked away in these controllers. No human ever looks at it. It never leaves the store, and it's overwritten after 3 to 7 days. So step one for us is put it in the cloud across all 500 of your stores. Step two, transform the data into actionable insights. The problem is actionable insights is a euphemism for a to-do list. And the last thing our customers want to do is purchase a to-do list. And so step three for us is automation. Transform the problems into solutions and address the opportunities invisibly behind the scenes using software. So at Axiom, we go to market with 3 subscription-based apps. The first one is Facilities Analyzer. This is enterprise visibility. The other 2 are premium apps. This is where we layer in the AI and the automation and data analytics. So Virtual Technician is predictive maintenance, basically solve problems before they turn into a big cooling outage using software invisibly behind the scenes. Or if an on-site technician is required, reduce the number of their visits per month, reduce the duration of each one of those visits, and eliminate as much thinking from their job as possible by basically packaging all these things up, batching and triaging, and packaging these things up in a way that makes so much sense for technicians. So where's the problem? How do I solve it? What's the data to back this up and show the before and after? And then virtual battery, Manik also alluded to this, and it's really cool. They're doing this with edge refrigeration. Basically, when you're talking about these large central systems, the opportunity is very similar. It's much bigger on a per store basis or per unit basis. Basically, the idea here is we can use this enormous energy consuming asset and we can flex the energy consumption of it. It's like putting a lever on the side of your refrigeration. You can kind of turn it up, turn it down on demand. And by predicting when building peaks are going to occur, we can basically pre-cool frozen goods in the grocery store. We're transforming the freezer aisle into a thermal battery using software. And so we can cause the building to consume more or less energy on demand by slightly overcooling those frozen goods, and then that's how we charge it. And then we discharge it by allowing the temperatures to rise back up to the initial set point. But obviously then we have to manage the temperature and the rate of temperature rise very precisely for each individual display case. So I'll pause there for today. We are in 7 major grocery chains and 1 large cold storage company. The ones that I can publicly talk about are Grocery Outlet, Sprouts, Whole Foods. I guess those are the ones I can. HelloFresh. Those are the ones I can publicly discuss. And yeah, we're getting into the hundreds of sites. So it's a really exciting moment for us at Axiom. We're growing incredibly fast. We're hiring. We're fundraising. We're struggling to meet customer demand right now. So yeah, we're looking for folks to join the team, and we're also we're looking for investors to participate in our next round of funding. So thank you.
Great, thanks so much, Amrit. Getting a little people here. Maybe Jane, if you can for just a second, but Jane will be going next from Harvest Thermal.
Okay. So, okay, great. You can see my screen. All right. So it's a real pleasure to be here. I'm Jane Melia. I'm the CEO and founder of Harvest Thermal. And we're going to stick to this theme of cooling and heating and load shifting and talk a bit about the problem of homes. So how can we transition our homes from gas affordably and comfortably, and how can we do that at scale? How can we do that also without harming the electric grid and maximizing the use of low-cost renewable electricity? So these are the problems that the Harvest Thermal team has really been tackling. And we've got great results. We're able to reduce emissions by 90% compared to gas and bills by 40%. And we do that while making the electric grid stronger and cleaner. So that's a path to large-scale home electrification. So today I'm going to really talk about what we do and how we deliver those benefits. So most of the energy use of homes, 2/3, is actually for heating and hot water. And that's typically from burning gas in your furnace, your water heater, your boiler. Right now, putting solar panels on your roof is fantastic. But if you've got, as most of us have, 1 or 2 gas combustion engines in your closet or garage, that's only tackling a small part of the issue. We need to get that gas out of our homes, but it's hard to do that comfortably, cost effectively, and without harming the grid. And those are the challenges that Harvest is taking on. So what does Harvest do? We deliver electric heating and hot water for homes, always using the cleanest, cheapest electricity for the lowest bills and lowest emissions. Our device is the Harvest Pod shown here. It's a smart IoT controller combining electronics and flow controls, and it's the brains of the overall system. It operates just 1 heat pump when electricity is clean and cheap. It stores that energy in a thermal battery and delivers it for all the heating and hot water needs of the home, completely decoupling electricity use from delivery of home comfort, just with 1 heat pump, 1 tank. It works with forced air, it works with radiant floors, it works for existing homes and for new homes, and it's simple and cost-effective to use and install. You think of a Tesla car sometimes as a computer on wheels. Harvest is really a computer on a tank. The system is smart, it's integrated, cloud-connected, with machine learning to optimize performance and user experience. It's also demand response capable for VPP integration, which I know some of the earlier speakers have highlighted as something that's really critical. Without the Harvest Pod, heat pumps run on electricity at the worst times in terms of cost, pollution, and grid stability. So let's take a look at how Harvest solves those issues. So here's a chart showing the average daily emissions for a grid with significant renewables. It has the classic shape of the duck curve, which I'm sure most people in the audience are very familiar with. High emissions and production costs in the mornings and the evenings, low emissions, low electricity productions in the middle of the day when we have a lot of solar on the grid. Now, we need to transition our homes from gas, particularly for heating and hot water, the largest energy loads on the home. But the challenge with that is that they operate instantaneously to heat the home in the mornings and the evenings. So they're not really benefiting from the low emissions times of the day and the low cost times of the day. This makes it a challenge to scale, and it's putting a huge additional load on the grid, up to 40% increase in peak load in the mornings. Now, wouldn't it be great if we could sometimes use an inverse duct curve? Well, that's exactly what Harvest does. Just using one heat pump and one tank in our Harvest pod, we're shifting those 2/3 of the energy use to the middle of the day, from peak to off-peak for that full heating and hot water load. So let's look at the results. As I mentioned before, all our homes are now reducing our emissions by over 90% compared to gas, and halving emissions compared to the next best alternative, which are those great regular heat pump systems. We do that while slashing bills, and this delivers a positive payback compared to all alternatives and super comfortable homes. As we like to say at Harvest, Harvest is best for the planet, but also best for your wallet or best for your home comfort. Here, I wanted to just show load shifting in action in a couple of homes. Green line is showing when Harvest is actually drawing electricity. Orange line when the home is using that heating and hot water, completely decoupling the two. I want to end with some of our homes in action. We currently have about 20 homes deployed in California. We're expanding up the West Coast later this year. But every single home, as you can see, is reducing emissions by over 90%, and they're reducing bills by between 20 and 48%. And that's it from me. Thank you very much for your attention. I look forward to any questions later on.
Thanks so much, Jane. And now I'll pass it to Chad. Chad, let's see if we can get the slides going.
Alrighty.
And while he's doing that, it looks like there's a question for contact info if you're willing to share them in the chat or with Gil directly. Great, Chad, I can see your slides here. Perfect.
Awesome. Hi, everyone. Good morning. And I'm Chad. I'm the SVP of products from SPAN. And today I'm going to talk to you about a very important piece of technology that is in all of our homes. And generally, we only interact with this device when there's something wrong, right? So, you turn on the kettle and you turn on the toaster, and the circuit breaker trips, and you have to run out and go switch the circuit back. But with electrification, we're going to be running 4 times as much electricity through this lowly box that has been, it was designed over 50 years ago. And at the time when electrical panels were designed, there was no concept of having your own generation at home. There was only big, huge power plants located somewhere else, and then feeding that power single directionally to your home to a small number of electrical appliances. With electrification, we're going to be pulling a lot more electricity through this box, and we need to know where that electricity is going and how to manage it so that it's not a big tax on the grid. We recently worked together providing data to CANARY Media to realize that SPAN can actually manage and optimize the electrical consumption within your home using smart panels. And this will greatly reduce the impact on both your home and also the grid at large as we electrify, adding heat pumps, electric cars, and induction cooktops to all of our homes. This is our panel. So this is the SPAN smart panel. It's got monitoring and control built in all in one device, and it's available to be installed throughout the United States. And we are installed in hundreds of homes in every state throughout the country. Now, we also are offering a SPAN Drive, which is an EV charger. As I said, with electrification, we quadruple the energy consumption, and 50% of that is generally adopting an EV in your home. And with EVs, we are seeing a large number of consumers having to upgrade both their utility service and their electrical panel. And we are able to reduce the time and cost of installing an EV charger by monitoring and controlling your EV charging to fit within your existing infrastructure. So what that means is we can charge your car as fast as any of the cars on the market just by monitoring your grid connection and then dynamically adjusting the charge power. We can also charge on sunshine, which allows us to change the charge power of the car to match what your solar panels on your roof are producing. And all this is backed up by a really consumer app. And this app provides information about where your energy is coming from, whether it's coming from a local solar or battery storage, or even if it's on the grid. We look at the open data about how energy is flowing into your house from the grid and can provide information and insights into how that energy is being produced, whether it's solar, whether it's wind, whether it's nuclear, or internal combustion or combustion resources. We also offer resiliency. So we allow you to prioritize your loads during an outage. And that's seen on this third image here. And finally, we offer these insights in a real-time feedback notifications to your phone and also into an activity feed, really connecting you with your energy consumption and helping point you to really important insights, whether it might be, hey, it looks like you could upgrade your refrigerator and improve and decrease your electricity consumption, or something as simple as, we noticed you just left the house and your oven's still on. Would you like us to turn it off? The really cool thing is that we're able to actually offer all this insight today. So I really encourage you all to download our app and try out our simulated home and see what an electric home powered by SPAN can look like. Thanks for your time and look forward to talking to you more.
Thanks so much, Chad. And I see lots of questions coming in here. So thank you. Keep them coming in the Q&A. I'll try to collect all of these and we'll get to them at the end here since we have one more speaker. So I'll turn it over to Charlie.
Sherrie, can you let me know when this is up and running?
Yes, we can see them. You just have to make it full screen.
All right. How's that?
I'm still seeing the presentation view.
Oh, weird. Still presentation view?
Still presentation.
Should.
You might be able to just go through it if you're not able to do full screen.
I'm gonna have to do that. Sorry, I'm not able to figure that out. But it's great to be here with you all today, and really interesting folks and companies and ideas before my presentation here. So I enjoyed listening to you all. Thank you for that, and many tough acts to follow. I'm excited to talk to this group about electrification and decarbonization and all of the different technologies that exist in the world today to help companies and individuals decarbonize their operations at scale, and all of those that are coming out, quite literally by the week, interesting software, interesting hardware, and things of that nature. So I've really enjoyed being in this space the entirety of my career, but I think even in the last 2 to 3 years, just sort of watching the ramp rate of innovation and ideas. It's going to be fun, over the next decade to watch these changes. And what Alturus is focused on doing is helping large corporations, municipalities, higher education institutions, and the like, decarbonize their operations at scale. And it's our goal to help them do this rapidly with no upfront capital investment required. So if you're operating a large enterprise and you're looking across the world of technologies and equipment and retrofits and things that your organization needs to implement to get energy savings, cost savings, and emissions reductions, there's typically a tremendous amount of capital that needs to be invested by your organization in order to implement those solutions and start moving down that road. And what Alturus is focused on doing is helping companies set up a programmatic way under which we would fund 100% of those project costs and then provide those emissions reductions throughout the term of our agreement, along with reporting, measurement, and verification to help our customers achieve their goals in a decarbonization space. And it's a really innovative new model and a new way to get there. And I think the reason that it's getting so much traction at the moment and will continue to, is because the existence of climate change has really forced companies to rethink how they're going to manage their energy spend, manage their carbon emissions with their current footprints and their businesses as they grow. And what I've got on this slide here is just a simple example, operational and sustainability goals of a Fortune 1000 company. And this is, what we're starting to see more and more, which is a 30% emissions reduction by 2030, 100% renewable by 2050, and then growing even beyond that. Many companies that we work with are focused on how can they decarbonize their supply chains. So we work with large companies as well to help them understand how to help their supply chains understand how to implement these types of programs as well. And it's
Charlie, we're still seeing your title slide. You might want to
Josh, I'm sorry.
There you go.
Okay, I'm just going to use this. I apologize, you all. The rest of my colleagues on here had innovative technologies. I'm a finance project geek, so I'm not killing it in the tech sector, but
you're doing great.
I can barely operate a PowerPoint, so we'll stick with this. Thank you for the heads up, though, Sherrie. Appreciate that. So, just talking about, I'm going to go back to this slide for 1 second, just because it's something that I've seen sort of in the last 3 years. I've been in the renewable space for almost 20 years now, and I've always, in the last probably 10, 12 years of working with corporations, they were setting sustainability goals. And oftentimes you'd meet with these companies and they'd say, yeah, we did that, but we'll do something about it if it's convenient. And that wasn't sort of unique. That was the majority. And I think what has completely changed in the last 3 years is a lot of these different companies are saying, we've set these goals, we need to hit these goals, and we're committed to hitting these goals, and how can you help us? So that's been really exciting. And I think, some of the others that are presenting here are showing the different technological advancements that are coming down the line to meet those needs in a really sort of economically attractive way for the end users, which I think is great. So what Alturus does with our customers is we work with them to identify projects, fund and implement projects across their enterprise and at scale. So if you've got 20 manufacturing sites in North America, we would work with you to prioritize project portfolios. And this is, this can be a very, very wide variety of technologies, right? It could be as simple as LED lighting. It could be as complicated as a combined heat and power plant that is engineered and designed for fuel switching as that becomes more and more economic. So, our capital and our contract structure is very flexible to drive, adoption at scale and with speed. So that multi-technology approach that we bring, I think is very interesting. And our goal on the partnership side with our customers is really to be our customers' right hand in these partnerships, right? The individuals that we interface with, they've got full-time plus jobs already. So not only is capital a constraint to getting these projects implemented, but hours, people that have bandwidth and capacity inside of their roles don't have the capacity to identify these projects, to project manage, to implement. And so we do this for our customers on a turnkey basis. The model in which we do this, we do it under an energy services agreement is what our contract is called. And the benefits of this approach is that for our customers, there is reduced cost to them immediately. There's no capital investment required. And we are guaranteeing the outcome of these projects that we install. So if we're saying, okay, you're going to reduce your energy consumption by X, there may be a thermal load consumption component or a thermal load delivery component. We will guarantee those KPIs to our customers. So in addition to simply providing immediate savings, we're measuring those savings, we're verifying those savings, which makes it easier for our customers to report back their progress against the goals they've set. And then if our equipment is not functioning properly in delivering those KPIs for our customer, we owe them a payment to make whole for that. And these energy as a service programs carry several benefits. I'm very biased, obviously, because this is what we do for a living. But key to that is the elimination of the requirement for capital investment and the removal of operational risk. So we typically bucket the benefits in two categories. There's financial and there's operational. And one of the other key benefits of the energy as a service model is that these projects and their savings are delivered without an impact to the balance sheet. So they are categorized as an operational expense, not a capital expense for these companies, and not debt. So that is hugely beneficial. It's similar to AWS or Microsoft Azure software as a service. However, you're delivering electricity savings and other outputs. From an operational standpoint, one of the benefits that we provide our customers is scale, right? They might have the need for $1.5 billion over the next 5 years across 10 facilities to meet their sustainability targets. That's a really, really high bar and a high hurdle. So in addition to just capital, we help them prioritize how they're going to get there, and we help them with that rollout on a turnkey basis. It reduces the administrative burden needed from a person standpoint and just resources. It's always a challenge. So making that rollout, making the adoption of this model and of these projects easier for our customers is really core to what we do. And we're just getting started, right? But we've got a great track record. Our team has been focused inside the corporate and industrial energy space for a very long time. So we've deployed a substantial amount of capital into distributed assets, in our careers and in our company's history. And like I said, I think we're just getting started. The amount of potential that exists for adoption out there is tremendous. So very excited to speak to you all today. Thank you for having Alturus as a part of this. And thank you.
Great. Thanks, Charlie. Perfect. So there's lots of questions that came in. I'll try to get to maybe one per speaker in the next 6 or so minutes. So first up, for our refrigeration companies, Manik and Amrit, I know a lot of cooling can be lost in the opening/closing of refrigerator doors, which is probably why so many stores and homes may be overcooling. How do your products address this issue when trying to reduce or shift electricity demand? And how do you manage the risk of temperature shifting too much and affecting products and quality regulations?
Yeah, happy to jump in, and Amrit, we can tag team. So I'll take one, you take one, if that helps balance the load. Sorry, making cooling jokes. It's too early in the morning for cooling jokes. I think it's a really great question, and it's one of the reasons why refrigeration has historically been hard to tap as a controllable load. You don't want to end up with a safety or compliance issue. So most people overcool systematically and don't want to play around with refrigeration. One of the reasons we're getting traction is because we started by building a best-in-class monitoring product, which gives you 24/7 monitoring. When you can see what's going on inside reliably, wirelessly, and off of a battery power, you can actually start playing around with the load. And so the reason we built monitoring first was we wanted to ensure safety and quality. You don't need to be a Harvard-trained lawyer to know that if you don't ensure quality and safety, you're going to have a hard time convincing commercial customers to let you turn refrigeration off for very long. So the monitoring layer that we built, I think, is one of the the guardrails, if you will, that opens up the possibility of dynamic management. I think related to that, there are a number of fail-safes in our controls products, so you can override and turn things back on. We use extensive buffering, so we have pretty deep buffering in terms of the thresholds and the number of degrees we stay outside of safety and quality limits. And that's largely a function of what's inside the fridge or freezer and how deep frozen it is. Sadly, from a public health standpoint, but happily from an energy standpoint, from a public health standpoint, most Americans eat pretty healthy. As a result, a lot of our food is frozen and often deep frozen. You think of the typical quick service restaurant or the typical, frozen food section. What that means is there's a lot of battery power sitting out there in refrigeration, and you can tap it a lot more effectively.
Yeah, well put. I mean, when you're thinking about leakage of cooling, you're absolutely right. There's a big problem with that. A lot of the customers that we serve, the big retail grocery chains, a lot of them are coming around to the idea of putting doors on cases. It took decades, but there are still a few notable holdouts who believe that adding doors will ultimately reduce sales and negatively impact market merchandising. We're selling to a somewhat different subset of customers in Manik, where our customers already have really advanced sensing, hundreds, if not thousands of sensors throughout the store. And so for those folks, they're typically not, there are some overcooling opportunities for sure. But ultimately that provides us with all the data that we need to really provide, an enormous amount of safety and basically, make people feel really good about what we're doing, because there's so much data and so much telemetry there already, especially when we're doing any sort of load shedding. And we always we only focus load shedding from our virtual battery app is our the one where we're transforming the freeze dry into a battery, like I mentioned earlier. And we always pre-cool before we load shed, so that means that we're driving the temperature of those frozen goods down by a few degrees. The really cool thing here is that, you think about the USDA, the FDA, the food safety team at grocery chains, they all care about, this magic number of the maximum temperature. You can never let the food or the product or the discharge air in that display case get above a certain temperature. But there's no minimum temperature. Nobody cares about how cold things get. And so that enables us to, we're not, making a huge excursion here, but a couple of degrees. If we can push the temperature down by a few degrees, that enables us then to modulate down refrigeration energy consumption really substantially for a period of 4 hours, 5 hours, 6 hours if we need to.
Great, thank you both so much. All right, Jane, over to you. What are your thoughts on solar thermal for heating water in states like California and Arizona? Any reason why it hasn't gained popularity?
That's a great question, because people think a lot about solar thermal, particularly about the hot water space. I guess I'd like to take it from the angle of the broader problem about the heating and hot water as well. So not just the hot water, but the heating. Solar thermal works great for summer, but typically you're going to need some kind of backup source for the hot water in the winter, particularly if you want to use it for your heating in the winter. So that means the cost of the additional infrastructure, be it electric resistance or heat pump or gas to top that off. Now, so what that means is you're purchasing the solar thermal and you're also purchasing the additional infrastructure. The beauty is that heat pump technology has really improved a lot over the past decade. I had solar thermal on my roof back in the 2000s. I no longer need that anymore because heat pumps are just so efficient. And if you can actually use the tank as a thermal battery, as we're doing with Harvest Thermal, you're actually capturing nearly fully solar electricity to heat your home. And you can do it for the full heating and hot water load without having to buy a backup system. So solar thermal is only a part of the solution, and it ends up therefore not being cost effective when you can have solar thermal storage to deliver the whole load using fully solar electrons.
Great, thanks so much. And I will pass it over to Chad. Chad, please compare for me how a smart panel can replace the smart assets of individual appliances and what the smart panel might not be able to provide that individual appliances can.
Yeah, this is a great question. And basically a smart panel is able to go into an existing house and immediately make all of those appliances smart. So the other speakers talked a lot about monitoring, and monitoring is really key. You have to be able to see where and how you're using energy. So we're able to see how and where you're using energy throughout your whole home. And the panel has a view of that energy usage and can make decisions based on that, plus you as the homeowner's preferences. And then a smart appliance might be more granular, right? So where we would just turn off or on say a water heater, for example, you might be able to adapt or change the thermostat setting of a smart appliance. And the cool thing is that SPAN, being a computer built into your home with over-the-air updates, we're constantly integrating and updating the SPAN panel and adding integrations for things like thermostats, so that rather than it being a on-off control, you can actually set temperature settings within your SPAN app.
Perfect. Thank you. And then Charlie, you'll have the last question here. Do you provide the engineering and or manage the contractors, or just finance and planning? Is Alturus the contractor?
So typically, we will partner with solutions providers and engineering companies, depending upon the types of initiatives our customers would like to utilize. And oftentimes we partner with those companies when they have a customer that would like to utilize our services as well. So it's a nice symbiotic environment. We, from a contractual standpoint, so Sherrie, if you were our customer, your contract would be with Alturus and only Alturus. So we provide sort of the one neck to choke approach. And then we work and manage with the contractors and the implementation partners on the back end.
Great. Easy enough, hopefully, for all of your customers. And great. So I know we're a little over here. So thank you, everyone, for joining. We couldn't get to all of the questions today. So I encourage you to reach out to folks using the people function over on the right-hand side with the chat box, or folks can drop their contacts directly into the chat box here as the session is ending. And encourage you all to follow up. Lots of great questions and discussion going. So thank you again to all of our panelists for joining today. And I hope all the rest of you enjoy the rest of the event. Thanks, everyone.